architects, talented designers, enthusiastic ABID members, and our friends from the media. It is my pleasure to welcome you all to this remarkable event, a seminar on parametric design, both in interior and exterior design. I'm sure the learned discourse of the illustrious speakers and panelists will go a long way in honing the design skills of our fraternity. We in ABID are always keen to evolve. Our sense of purpose is best reflected in our various activities. While our exhibitions are panorama of creativity, our seminars are no less enchanting. In order to keep our members updated, we organize trips to some of the best exhibitions both in India and abroad. With an eye to improve the posterity of designers, we encourage more and more students to participate in our programs. This evening also, a few students who amply showed their mettle are here tonight to learn something from the erudite scholars on the subject. It is a crime to waste any more time from the learned discourse, which is likely to follow now. Thank you.
Thank you, Kamleshi. Moving on with our presentation, I now invite Vidisha Nimachwala to introduce our first speaker, architect Monish Rirapuru.
Hello everyone. Architect Monish Siripurapu is an award-winning architect and the founder of Ant Studio, a multidisciplinary design practice that explores the intersection of art, nature and technology. An alumnus of SPA Delhi and IAAC Spain, Monish has a keen interest in computational technologies, robotic fabrication and biomimicry, which are reflected in all his architecture and design projects. He is also the founder of Cool Ant, an innovation think tank that aims to provide sustainable cooling solutions for all. Monish's work has been published across many well-renowned architectural journals and platforms, such as World Economic Forum, Architectural Digest, Inhabited, and Arc Daily. He was invited to speak at the prestigious 361 Degrees conference in Mumbai and as a keynote speaker at the World Environment Day 2018 event held in New Delhi and at a TEDx event. He has been also invited as a lecturer and exhibitor of his works in various IITs and IIMs and also by international organizations. So friends, please welcome architect Monish Sripurapu.
A very good evening, everyone. It is an honor to be here to share some of the work that we guys are doing. And Kolkata has been really enchanting. I always looked up to this side of architecture and more importantly, the passion towards art and literature. And I think this is something that really drives in a lot of, I think a lot of culturally the whole essence actually is relevant to this place. So it's definitely an honor to be here. Thank you so much for having me in the first place. So, Ant Studio. We are a practice based out of Noida and Delhi NCR. What we're trying to do is to see if we can bring together art, nature, and technology together. I'm an architect by training, but I have done my specialization in robotic fabrication. But then when I got back to India, the whole idea behind the practice was that to see if we can combine nature into the built forms in various ways. And it has been a driving force ever since in our works, to see how we can actually combine nature in the form of either like drawing inspiration from the form and the shapes, or to see if we can copy the process in nature. I think these are two things. I mean, I'll definitely be talking about these three aspects in a design. But the third, which is the most complicated, or which I think we really love doing, is to see if we can mimic an ecosystem. And these are some of the three governing principles in our work. And yes, today I'll be focusing on parametric design, but also I'll be talking a little briefly about how parametric tools can also inform research. And you can say more than the forms, I think that's where we are trying to see if we can bring in natural forms and the process into the design. So the first project for the evening is Anahat. This I have done, I think 7 years ago. And definitely, I think if I do it now, probably there are a lot of learnings and I'll do it differently. But the biggest, the takeaway for me personally from this project is, while I think the form and everything is definitely very important, how we implemented it in India, because especially, like I said, I've had my specialization in robotic fabrication. I was really high on energy when I got back to India after my master's, and I wanted to bring this all technologies and everything into see how we can actually do it in here. But then the reality is very hard. Like while I think we are talking about robots and future and all of this there, back in Spain when I was doing the program, when you come back here, we are even struggling to find this basic technology, the CNC and other stuff in the projects, and that is the ground reality in here. So these are some of the built images behind this of the project. But the story behind this is not just about the parametric architecture or the form. So what you see on the bottom is an existing building, and what we build is a building on top of that, like using the structure, which is in a way it's more of an adaptive reuse structure in the project. And these are some of the finished images. And so yeah, this is what we got. What you see on the left, it was the building that was existing, and what you see on the right is something what we did with it. So the story behind the project was, when we first got introduced to this, the client was in a way, he gave us an option whether to wipe the whole thing clean and then design either something on, and start from scratch altogether, or if you can do something with it. So we proposed to the client that, what if, the structure was intact, just that the planning was miserable, because if you notice, all the rooms are actually facing towards a garden, so there is no common living room and all. Architecturally, it was a disaster. So, but the structure was, structurally sound, steel, there's nothing wrong with the structure at all. So we proposed to the client that we will retain the structure as it is and utilize what was already there, and see if we can build on using this on top of that. So yeah, amazing horses in the project, which were also the guiding force behind the design. So without much ado, this was the project, like I said, how it was. And what we proposed is this structure on top of this with a pool underneath. So the idea is that in the planning, because there are these horses which are a very integral part of the site, the building should provide that, these are really wild beasts. These are polo horses, and when they run in it, it's very difficult to control them. So the architecture was designed in a manner that they kind of protect the horses from jumping into the water, and in the process, they can actually hurt themselves. So what we did is that, we took the structure as if it is coming down from the building, from the ground, and it climbs on top of this existing structure, what you see over there, and so that it unifies the ground and the structure, what we proposed over the top, all in one. And to see, and provide this, like I said, the whole process of the steel, I can go on about the details. Given the sensitivity of the time, I'll skip a few details and show you. Yes, I think this is what I really wanted to talk about in this presentation is, while I think design is one sort of things, in India, when we're actually talking about it, the reality is, what you see on the top right corner is that we had to actually work with, there is no CNC. Even the roof, it was all done manually on ground. So we had, like we make in physical models, I think we had to do this half cuts on the steel and then bend them to get a precision that is almost 5 to 10 millimeters. And so one might ask me, why not CNC? I'll come to that probably in the Q&A. And so each and every member was different. We have optimized it. But then the most satisfying and the challenging part in the whole design is that you see those beautiful trees, which were part of the site. So we managed to take the structure in such a manner without even making sure that not a single tree is actually cut in the process. So these are some of the images from the construction, how it was done manually. And yeah, the whole assembly process was actually a lot really fun, and at the same time it was quite challenging to get the precision what we intended. So yeah, these are some of the images from the process, what we tried doing, and yeah, how it was. So finally, this is the end result, what you see over here. So this particular structure wherein the whole thing, like I said, even though it was fully manual without any kind of advanced manufacturing and tools, we managed to get the precision that was, like I said, with an accuracy of 10 millimeters. So the interesting story behind this is we got these zinc panels on top of this, and each and every panel in this is different. But we came into the project with a promise from the manufacturers that all of this is going to be automated, and everything will be machine made in factory, and they're going to come and just assemble it. But that was not the case, because we ended up actually getting the machine on the site, manufacturing every piece which is independently, every panel is different, and had to do it on site. So this was, like I said, this was something that was, like the course corrections and adaptation that I think most of us as architects we have used to doing. And this is some part of the structure wherein we had these trees coming in, so we had to make this room for these courtyards and stuff like that within. And you can, even this parametric louvers, what otherwise are actually having these different angles, are treated like this is the detail behind this. It's a very simple, like any other, the window or the louvers that we do in this. And finally what we have is this louvers wherein each and every angle was designed to cut the south sun and the southwestern sun coming into the project, and yet maintaining the view from the inside to the outside, to the lawns. So that was the idea behind the form, and this is the final product, what you see on the site, sitting on top of the existing building. So these are a couple of these courtyards that were punctured into the project, and we also had these panels that were left out for light and ventilation and so on. So this is the journey, the first one, and pretty happy with the end result. But obviously that gave us a lot of the boost and encouragement to go forward, saying that we're going to do everything with parametrics in real. So we went ahead and tried proposing this kind of structures to other projects and other clients. Yeah, but before I go into that, there's another interesting part of this particular project is so when we were dismantling the roof earlier, so we came across a lot of steel that was removed from the roof. So what we tried doing is that not a single member of the steel was actually wasted. We recycled it, but not just the steel. The terracotta tiles that you see on the top, the roof tiles, we recovered each and every tile, and the steel what you see below, all of this went back into the structure. And we used the same tiles within the project to make a parametric sculpture using this in a form of a sculpture in the same living room. And this is the final outcome of here with a skylight on the top. So yeah, this was the story behind this project. And this is some of the images of what we ended up making. So I was saying that, that was, like I said, we felt really encouraged, and we thought, we can do now anything. But then when we went back to other clients, it was not always a happy ending. So a lot of no's and a lot of unbuilt projects. But the thing is that, but with the confidence that yes, since we made one, we can actually make many more using the similar technique and similar learnings and so on. This was another project that we proposed for a client in Golf Links in Delhi. And I think while the design and everything was very well received, but then the client always asked, what if we want to make one more floor, what will happen? So that kind of changes the plans much more disastrously than we anticipate. So these are some of the other works. I'll very quickly glimpse through some of the other structures where we are trying to see if the parametric, the architecture can be integrated with local vernacular methods. So this was a project in Kerala. and it sits like a tripod. The whole idea behind this is while the sloping roof, the wood and materiality kind of tries to uh, mimic or like imitate the local architecture, but then there is this beautiful flat terrace on the top, which is the whole idea is while we are getting the sloping roofs and all that, with this fluid forms, we were able to carve out a flat thing so that one can even enjoy the whole landscape on a flat terrace while having this, the roof. That is, like I said, typical sloping and so on. So this is one of the latest works that we guys are doing right now, where there's a client in Lucknow, and so when he first came to us, his brief was, I want a house like that of an Iron Man. And I thought that was crazy, but there's another client who got a Ferrari and said, okay, I want a house like a Ferrari. I'm not kidding. It was serious. So these, I mean, for them, when they think of parametric and these curves, that's the references that they look up to, the curves and the streamlines and all that. So this client, the story here is, there's a golf course right in front, behind the project. And the road is behind this building. So he wanted to bring the car from the rear, from the main road onto the first floor and drop off. And he wanted to look at the golf course every day when he's dropping off. So he said, I'm going to take the car here like this. And so we left a sandwich like this, disconnected the building, the top and the bottom, and had this green entrance in the middle, so that when they're dropping off, they get the view that he's looking for. And the whole building, from the roof, the slab, and everything is curvilinear. So one might, like, so we had to do a lot of research in trying to make this possible, because we are not talking about the roof being curvilinear. We're actually talking also about the floors being curvilinear and still functional. So for those of you familiar, there is a concept by Daniel Piker called rheotomic surfaces. So what rheotomic surfaces mean is walkable surfaces. The slope is such that you can walk, but not too slopey for the furniture and everything to roll down. So this was the wife, she was really concerned about it. What will happen to her furniture? Will it start rolling, and how are we going to place the beds, and how are we going to place the chairs and all that? But it was interesting, but I think we managed to resolve the even the structure and all the everything, making sure that we got the right amount of curves and the right amount of flat surfaces. So that was not the case, and still getting what they were looking for. So yeah, we are optimistic that sometime soon. Any questions in the meantime? So what we did is we balanced the floor area and the spaces and all the areas where there is no furniture is having this curve, but the rest of it with the furniture and everything is actually flat. So we had to do a lot of iterations to make that work, wherein when you're walking, when you're moving around the house, it's actually a smooth curve, and but you're still getting it. So the inclination, what you see here, if you look at it in detail, in here, there's actually a pool with somebody over there. So the slope we are using for the water. So we managed to place the functions in such a manner that we are able to fit in these the spaces accordingly. So in the within the slope, and also had these gradual steps and so on. So different ways, actually not one particular detail, wherein we can actually balance that to get the balance of both. So yeah, this is parametric sculpture called the pangolin. The idea behind this was that this was a workshop that I had done, but then while we were doing this, the main thing was, I mean, we all do work that is very visual and very communicative, which is very much driven by the form. But then just before the workshop, just a couple of months before, I came across this, a very sad article just outside Gurgaon. In one of the villages, the villagers killed a pangolin thinking that it is very creepy and evil because the shape is such that it's scary. And for me personally, I thought it is beautiful creature. The whole thing, I mean, the point, the intricate, the form work, and everything on the pangolin is extremely beautiful. So we thought, okay, what if we take that as the inspiration behind the form for this, the pavilion, and also in the process also talk about pangolins and try to see if we can create awareness through the work. And this is some of the other work wherein, while I think the forms are pretty much, they speak for themselves, but the idea in here is it's a commercial complex where commercial complexes are typically driven by glass facades and building envelopes. So we thought we can actually combine ferro cement with exposed brickwork and to see if we can reduce the amount of radiation that's entering into the building with brick and trying to see if we can, in a way that can reduce the air conditioning load. So there's a lot of work in the segment of how we can, I mean, to talk about the thermal comfort and all. But this was one of the, like, an interesting case study for us also. You can say it's also like a social experiment to see if we can use that as a means to convince the client that instead of going for a typical glass building with a lot of glazing and the signages, like we can redefine the forms wherein they're attractive, they're catchy, because that's one of the parameters for commercial complexes. They have to be catchy for them to attract the, becomes a storefront in a way, too literally, so that they can bring in the people into the project. And yeah, I mean, we got pretty much good response for this. So yeah, this is some of the other stuff wherein to see if we can combine, I mean, the parametric design with exposed break and ferro cement, which are the materials that we kind of deal with. The second part of the presentation now talks about parametrics, but in a slightly different manner. This is the research side of Ant Studio, wherein we're trying to see if we can work on passive cooling, wherein talking about energy simulations and energy modeling to see how we can optimize the spaces to keep them naturally cool with, what do you say, a passive design. So I'm sure, I think most of the audience in this room are pretty much familiar with the vicious circle of global warming and air conditioning. As we're trying to cool our spaces, we end up actually heating the exteriors. This is a, I mean, I really still can't, I read this every single time, but I still can't get my head around this 100 million tons of CO2. I can't imagine what this 100 tons of CO2 actually means. And 1 billion air conditioners are required by 2050 just in India. Because every year, there is an increase of 15% of the people, because we are being a growing economy, are able to accept, have more and more air conditioners. I still can't think what, I mean, what size this 1 billion air conditioners actually mean, and it's pretty daunting. I mean, if just in 2 days, in 2019, the amount of CO2 was released was equivalent to the whole CO2 released in 1902. And this I'm talking about 2019. We are in 2023 right now. So yeah, I mean, so the whole idea behind this work is to see if we can look at building envelopes like products designed for different climates. One of the biggest thing, I think, while we keep saying that today traditional systems are not being used and a lot of this stuff, one of the major reasons that I do not have the time and the bandwidth to think anymore. The attention span is limited to 10 seconds of scroll on internet or on Instagram. So people really don't want to think about what is it that one has to do to make our buildings work. That's far, what it was traditional knowledge and wisdom earlier is now rocket science. Because we don't want to and the whole thing is, there is this question about, do these things work? What is passive design? I think this is the cynicism that we see in a lot of people, while these systems have worked for thousands of years. And it's only in the last years. So what the objective behind this part of the work is, if we make it so easy for people to process this information, that if this can be, so people don't have to put their head into it, and all they get is a direct solution at the end result if they can start using it as products, the building envelopes, if they can become as a product, was the idea behind this. And so yeah, so this was the first work what we had done, called Beehive, with computational design and simulations, like I said, parameters in a different manner, to see if we can optimize the traditional systems that are there with the help of software and technology, what was already having, combine these two ends, wherein we can combine technology with traditional systems and relook at the outcome that is coming in. So this was our first work, what we did as a Beehive in a factory. Later we started taking it to building envelopes to see how we can adapt this on building skins, to see, like I said, it's a very simple direct evaporative cooling system, nothing very complicated about it. And but the complication started to keep in when we started looking at scaling this as a system for Yes. So, like I said, the idea behind this is to see if we can use these computational tools for analysis and like to see optimize the systems for design, but like it's not just purely the form. And what I was talking about earlier in the presentation about mimicking the nature, but not in its form, but in its the processes, how it works. And terracotta being a porous material and it absorbs water, we wanted to see how that material behavior can be used for cooling. So in a way, trying to see if building skins, I mean, terracotta is not a new material, right? We all have used earthen pots for drinking water. Water stays in it naturally cool. We all know that. But in this particular case, what we are saying is instead of cooling water, if we are dripping water in it and on top of the surfaces, as the air passes through it and comes out, air can be naturally cooled. So it's the same principle, but in the reverse order. Instead of cooling the, the water, if we can cool air, was the idea behind this work. And in a way, trying to see if we can translate this into larger scale, into the building interiors, and see if we can talk about thermal comfort and passive cooling, and use these softwares and tools as a means to arrive at the end result. That was the objective behind the work. And yeah, in the process, we came across these beautiful examples wherein the slaves used to fan the surface of the earthen pots for cooling for the pharaohs. And we have, I mean, tons of examples. Even here in this Kolkata, there are many traditional building envelopes and architecture that was designed to keep the thermal comfort inside, like naturally cool in extreme climates. So what we are saying is if you can use this and like, you know, unfortunately what happening is that every city now is starting to look similar. What used to be the building envelopes designed for specific climate and climatic aspects is not a common thing anymore. And so we end up actually having these, the buildings which could be quite generic in anywhere, any part of the country or any part of the world for that matter. So what we are saying is if we use the climates and the parametric tools and all the technology that is available to us to design climate specific and local specific building envelopes designed for a specific locality. And if that can become a product that anybody in the world can access these tools and the end result without having to put their mind into it. That was the objective behind the work. So like talking about nature and drawing inspiration from that, I'm sure most of us in the room must have experienced this, that the moment we walk under a tree, we feel naturally cool, right? Any idea what is the, average temperature drop if you walk under a tree on a hot summer day when it is 45 degrees? Anyone? 5 to 7? 2 degrees? 5? It could vary from 7 to 8 up to 12 degrees, and depending on the dry heat and which weather and humidity what we are living in. And that primarily happens because of evapotranspiration, which means the water is evaporating its 6th standard, wherein the water is evaporating from the leaves and the earth, keeping the surrounding environment cool. So what we are saying, this also on a bigger scale, this kind of balances the ecosystem, maintaining the seasons and whatever carbon dioxide, and we study a lot about this in our schools. So part of this work is if you can mimic that process of evapotranspiration in the building envelopes, so that these are what you see on the right are the aerofoils what we designed, which can be adjusted according to the solar radiation. The spacing can be adjusted, the angle to cut off the heat that's coming in. And in the process as the material, the air passes through this, the air becomes naturally cool. That was the idea behind. So that gives us a lot of flexibility in terms of design. So you can see that these are some of the work that we are currently doing, using this terracotta skins exoskeleton that can keep the heat away and bring in the light and also the cooling into the buildings. That was the core objective behind this, but at the same time not compromising the view, which is very important for office spaces and most of the buildings for that matter. View is really precious. So yeah, this is what you see on the left is the prototype behind this. And these are some of the other the works we are using the same concept to see if we can readapt this in modern buildings, parametric forms. Similar techniques, but integrating it into fluid spaces and trying to combine these two things together. This is a leprosy clinic that we're working on, wherein we wanted the privacy of the clinic from outside so that people don't see the leprosy patients inside, but at the same time, the skin can actually provide both cooling and also the privacy that is needed for the hospital. Because leprosy, you know that it is, the patients are seen as untouchables, and you should just walk into the society, you'll understand how these patients are actually treated in this vicinity. So we thought architecture like this can also help in providing both and also providing a space that is not just like you can say like an outcast, but rather celebrate, and this whole treatment that's happening provide a form that is very beautiful and art and fluid, and especially, I mean, I really like this site because this sits right under a tree, and what I was talking about evapotranspiration. So you see that the building is sitting just under a tree, so the form is derived to capture the rain and the water and also the leaves that are falling from the top onto the roof was the idea behind this. And yeah, almost end of the presentation. I think I'm running already late on this thing. I can see just a few minutes. So some of the last these works that we are doing, this is a fully passive house where the client wanted to use no air conditioners in the whole project. It sounded like music to us, so try to see with combining with courtyards and so on. So this is the last project for the evening. I want to leave with this, wherein the whole idea, like I said, most of the work, any other work that we guys are doing is to see if we can combine the advancements in technology, parametric forms, softwares and all of that, and also the material, the research with traditional architecture and materials. So this is a project in Hyderabad that sits on this rocky terrain. Hyderabad is full of this the surfaces that you see. So wherein the whole idea is this is simple terracotta roof and the fluid form, similar technique, but yeah, but the south is completely filled with this kind of exoskeleton that is protective. So yeah, I think that's the part of the presentation. And the last something probably for the audience is that one interesting thing that happened in this project is when we got this project, the whole site was filled with, this is the rock, and it is filled with mud. Client was ready to blast these rocks and build on top of it like any other building. So we suggested to the client that before doing anything, what if we scoop the land and see what is underneath and then use that as a base to make it. That was the idea that we proposed, and he obliged, luckily. And when we cleaned it, what we got is this beautiful rock, what you will be seeing here. This video no longer exists. Yeah, this is the last slide. So we cleaned it, and then not just that, with the help of this, the modern tools that are available, we 3D scanned the whole site. So instead of going for a regular survey, we managed to scan it, get the complete accurate 3D into the digital model. So what is otherwise digital, physical into digital, and use this as a basis for designing on top of this. So yeah, with that, I would like to conclude my presentation. Thank you. Are there any questions, or are we going to take questions later? Later? Yeah, thanks.
Thank you so much, Architect Monish. That was brilliant, I would say. Your use of sustainable material to create parametric designs was something to learn from. We've always seen parametric buildings made only in glass and metal, but you've used local material and fabrication at site was, I think everyone would appreciate using those kind of technology at site. Moving on to our next speaker, I invite Ms. Vandana Budhia to introduce architect Sushant Singh Verma.
Hi, good evening, friends. Sushant Verma is an international award-winning architect, design technologist, and an educator, currently leading RAT Lab Studio, Research in Architecture and Technology, that investigates intersections of design, art, and technology through architecture, interior design, and art installation. He holds a master degree in Emergent Technologies and Design from Architectural Association, London, and is a former architect at Zaha Hadid Architects, my favorite. A design entrepreneur at heart, he's actively involved with blend of technologies in creative fields and continues to develop a strong expertise in design technologies through his numerous ventures that correlate around design and tech, evolved over the last 15 years. Being actively invested into academic innovation, he is leading founder of RATLab Education, Smart Lab and EduLab India, unique at academic innovative to advocate use of technology in design through independently organized design workshops, programs, and online education portals. He has been a senior editor for the international design portal arc20.com and has authored 2 books on design technology and contributed to various publications in print and digital globally. Ladies and gentlemen, please welcome Sushant Rao with a good round of applause. Welcome.
Thank you, Abbott, for having me here. It's a wonderful stage being set. I can see a lot of parametric objects on the stage, so that's pretty cool to see. I just want to cross-check before we start. This is a PowerPoint presentation. Okay. Just checking if the clicker works. Okay, so ironically, I always start my presentation on a note where I talk about technology, I advocate technology, and we always have these tech challenges somehow. So that's the irony of it. But once we get started, I think we have some interesting tech to look into. Okay, sorry. I think there's a delay. How do you go back? Okay, cool. Working fine. Yeah, I'm good with technology, by the way. Don't trust this thing. Okay, so thank you, Abbott, for having me here. Wonderful stage being set. Thanks, Monish, for a wonderful start of the seminar. Some very interesting projects that I could see. And so today I want to talk about parametric design, computational design, which is what we do at the RATLab studio. And also touch a little bit about artificial intelligence as well, which is something we really feel is the sort of the next big thing. So just to get started, you know, I'm involved in a number of ventures. I also do a lot of photography and been doing that for a while. So these are a few of my photographs that I've clicked over the years, which usually I work with some galleries which go into different spaces. But the reason I'm kind of showing you that is not to just show off my photography skills, also a proof that I actually do photography, not just by phone. But the point that I want to make here is something else over here, is once this timer catches up with my speed. Okay, so you see this interesting photograph over here. I mean, I don't want to describe the photograph, it's kind of self-explanatory. It's a very interesting, cool photograph that you see over here. And then I want to show another one, which is this one, which is also pretty cool. I mean, the previous one was sky and cloud. This one is sort of sea with sunset and water and stuff like that. So yeah, I have 2 images over here. How many of you like the blue image on the left? Can I have a show of hands? I mean, you may like both, but which one do you like better? So blue one. Okay, the orange one? Okay, wonderful. So I have a very good audience over here. The orange photograph is not clicked by anyone. It's an AI generated photograph. This is the point that I want to make. So AI clearly failed me over here. The blue photograph is actually 8 photographs stitched together into a spherical panorama created by a human, but the other one is actually created by AI. So this is the point that I want to make over here. It's actually an award-winning photograph. It was actually in the New York Times as well. I haven't created the AI one, but it was a photography competition where the photograph won the award, and the artist later on revealed that it was actually created by AI. So that was quite an interesting thing. He declined the award as well, but let me get this into architecture now. So the part 1 of my presentation is what I call as design by humans aided by technology. And I want to read the disclaimer loud and clear over here that all of the images, visuals, projects that you would see that you would see next are not designed by a computer. These are not designed by a computer. A human mind, creativity, intelligence, smartness, experiences, and design capabilities are used in creating this. So So I run a studio called RATLab Studio. It stands for Research in Architecture and Technology. We're based out of multiple cities now, headquartered in New Delhi. And our works have been varied across different scales and domains and typologies of doing commercial projects, to stadiums, to facades, to installations at the airports, to residential, and lots of different things that we've been working on. But the primary backbone of all of these projects is computational and parametric design, which is, again, I would say that this is all designed by humans, which is what we typically do, but aided by computers and aided by technology, which is what we call as a computational design. So I'll just run through these images. I won't be talking too much in detail of any specific project as such, but if you can notice all of these, this is going a little faster than what I thought. But yeah, all of these projects, you can obviously see a coherence in terms of a very fluidic kind of a language. And I don't think this is anything to do with computers or technology, and I'm sure Monish will also agree with the kind of work that they do with the whole fluidic language. It's basically a design intent that we try to put in, and we use technology to aid that as a process to kind of design that for us or help us to fabricate, rationalize, or do various other optimization aspects. So these are of different scales. This is a furniture that we designed, we launched like 7-8 years back. This was, I think, the very early stages when parametric design was kind of spoken in India. This is 2016. I moved back to India from UK and US, where I spent almost 5 years, to kind of talk about computational design. And then that's when I realized that nobody was having a dialogue on these things. And most of our projects, we were exhibiting these installations, facade modules, all of these things were sort of computed in a manner. And of course, there were a lot of tools that were used. We use energy analysis principles, we use structural principles, which sort of become the backbone and the guideline to these kind of designs that we typically do. So it's not the aesthetics that we typically see. It's more about what goes behind the scenes to actually make these things work. Again, I won't talk much in detail of any single project as such, because I want to show really the variety of things that we've been doing. This is the residential space that we were designing, so doing this artistic kind of a feature where all of these are like sections. I mean, whoever is kind of used parametric design, you would know that this is the most simplest thing that one can do with parametric design, to be honest. But this is something which is in the early days that we were doing. We were trying to create a lot of fluidic surfaces and stuff like that. Then we also delved into different typologies, like we worked with a lighting company to work on chandeliers, where we designed this kind of a geometry. Then this is a stone factory which we were designing. The very interesting part of that was we wanted to create a low-cost experience center. It may not look like a low-cost experience center, but it was really low-cost, I would say. But how we really innovated in this was we actually used a recursive subdivision algorithm to kind of subdivide a triangle into multiple parts. So you divide a triangle by joining the vertices with a centroid, you get 3 triangles. You divide that once more, you get 9 triangles. You divide that once more, you get 27, then 81, and so far. So we kept on dividing that until the size of the valley reaches the size of the tool bit that is used to CNC mill the stone. So that was the process that we actually developed. So it was not only about creating an aesthetic out of it, but more of a fabrication rationale that we were trying to derive. And we created this system where we could build this entire skin, then measure the triangles, give the feedback into to an algorithm as a script that we had developed, and you feed in the triangle dimensions and you get the entire CNC data, which can just be transferred to a machine to CNC. All of these backlit elements, which actually looks like onyx stone, is actually white marble, which we typically use for flooring. So it's a very cheap material, I would say. This is a restaurant project we designed in Delhi, where we again has this faceted kind of a skin, which we really had to rationalize to sort of build it into a facade feature which goes inside. We also worked with a fashion designer many years back in Greece, where we kind of collaborated on a fabric where we sort of, sorry, it continues to go forward. Yeah, and then again, this is a toolkit development that we did for one of the facade project, where we created a system where The entire skin could be designed and all the fabrication elements could be computed. And while we were designing, we could also check the running length of CNC that will be required, thereby getting us the cost of CNC, about the materiality, and getting the fabrication data which could be transferred to the site. I think there is a video which you might have to click. Is that possible? If you go back one more slide. Is there a video? Okay, probably not. Yeah, that's fine. This is another facade project we were collaborating on with an architects in Hyderabad. It was for a corporate center. They actually came up with the whole Zaha project as an image to us, to be honest. I mean, I have to accept that. Yeah, okay, we want something as close to it as possible. And these are the challenges which we often come across, because we have been a collaborative practice where we've worked with many of our projects, at least in the initial phases of our practice, were collaborative in nature. We're working with different architects and designers. And a lot of times they came up with these Pinterest images and references that, okay, we want something as close to it as possible. But then how we had to like really step in to kind of have innovation work for us. Sorry, can you go back 2 slides? One more. And that's a video if you can click on. Yeah. Okay, so yeah, here you can see how we really innovated was after creating the geometry of and then the overall form, we went on to rationalize the geometry, how it would be constructed in a modular fashion in India, of course. I mean, the kind of curvilinear forms that you can make, you have to really customize those kind of joints and everything. So we really, we 3D printed smaller parts of the facade. We worked with the engineers to make them understand how to create families of profiles for the facade and break it down into, you know, a limited number of parts to operate with. And that data was also linked to the environmental design, analysis of the building, so that whatever we were doing was sort of relating to the environmental strategies that we were trying to apply to the building. So these were a few more projects, which again we were working on at that time. This was in fact in Kolkata. We were working with a steel company under a non-disclosure. Can't say the name, but yeah, we were working on creating this modular system for a facade company who was going to be possibly creating parametric panels in near future out of the systems that we had developed, and each system had to go through a lot of series of optimization and analysis, and how we can optimize the process of fabrication into a factory which can be modularized. This is what you see as an effect. From, I mean, on the left to right, you can see a gradient, but in essence, it's actually broken down into just 4 simple geometries, which we were operating with. And then all of this data is usually linked with the environmental design aspect, that what impact does this skin have on the daylight? What impact does this have on the radiation on the building? All of these angles that you see that we were working with was sort of having an impact to that. So we had to do a lot of analysis and studies, which we typically do in any facade project, to understand, okay, this particular facade will work the best in the south side, east, north, west, or any of the other side, and what is the amount of reduction of radiation that we can do, what is the amount of increase of daylight we can do, and all of these aspects we play around with. This was a stadium project we were involved with a sports design company. This was a renovation project for a stadium in Australia, where we were trying to optimize a double curved skin, but at the same time we had to sort of rationalize it in a manner that it can be used as solar panels on the top, and how can we maximize the amount of solar panels which get the, can create and generate a lot of energy. So again, on the top you see a gradient of, panels, and that gradient is obviously computed through the environmental analysis data that we had started with. This is a temple that we have been working on in South India. It's in Tamil Nadu, where another architect, some master were doing the master planning. We were asked to do this overall temple structure. This project had a lot of Vastu compliances sort of associated with that, which was all to do with the number 11. So we actually worked with a hendecagon. A hendecagon is a polygon, which is an 11-sided closed polygon. To be honest, we also did not know of a hendecagon. It's not a very common geometric shape. But the moment we got to understand, okay, 11 is a very critical number, because the clients were so obsessed with Vastu that the area of the plot was 11.11 acres. I don't know how they managed to do that, but that's the obsession with the number 11. So we were like, okay, this is a challenge and this is what we need to take it up, and let's play with the number 11 in some way. In fact, I have to tell you that in the initial conversations, the client also said, can my temple look like a number 11? And I said, no, we're not doing that. So, okay, let's be innovative here. So we played with a hendecagon. We created these systems which can become sort of a structural system in a manner to give you a large column-free space, because eventually we don't want a lot of columns inside. So we actually worked on a lot of iterations. We created a set of algorithms to create these structures, did the structural studies and analysis of each, and sort of evaluated these, which one works better than the other. And eventually, like, this was the form that we actually derived at, which was sort of made with these prefab structures of slightly curved columns coming in with a very fluidic kind of a shape inside, and you have this oculus where the light comes in. So it's very open kind of a form. And even the flooring pattern was sort of defined by 11-sided polygon. We moved around a few points to see what we can do, where we place the deity, and all of these kind of aspects. So it was a very interesting exploration. This is a project which is ongoing in Delhi. I mean, if you land in Delhi, you can see it next to the airport. It's in Dwarka. It's a large sky bridge being constructed. The pylons are under construction. So we were brought in onto this project to sort of make this project work, to be honest. I mean, that was a simple story. That, okay, we have a design, it's not working, we're not able to resolve it. How do we make it happen? So we worked with the engineering team. There were 2 engineering consultants, one in UK, one in India. It was initially, concept design was done by a Spanish architect, and there are 2 local architects and engineering firms in India, and it was a government project. So there were a lot of logistics involved, and sort of we were like thrown into this pool of experts to sort of control everything. So what we had to do was kind of redesign this entire project so that the design does not change, structure becomes workable, and do a clash detection, because these entire pylons had to hold a sky bridge. And sky bridge is a cable hung sky bridge, and all the junctions that you see had to be rationalized. All the junctions are like sort of different. So we had to really, this is something we call in our studio as a parametric BIM, that we sort of had to do the BIM modeling with a parametric design feature sort of. So we had to redesign the entire thing in a manner that every single junction could be detailed out in the parametric model, the data of which could be extracted as a line diagram and as an interface diagram given to the structural consultants to do the analysis, and that data was kind of fed back to us to do the changes. So it was a very, very challenging project. We were involved for more than a year. Our job is done on this project now. We sort of handed over the entire model with the drawings and stuff, and now it's being constructed. So, I mean, for those who kind of understand Grasshopper, you sort of understand like the complexity involved over here. So yeah, it was kind of challenging, but it was a very mathematical way of approaching this entire project, that you have this form, how do we mathematically rationalize it so that it structurally works, it functionally works, there are no clashes, and this was the end product that we had. This is a restaurant going on to another scale altogether. This is a restaurant in Mumbai which we designed, constructed a few years back, and all of these fins that you see is sort of are sort of numbered and different. Simple parametric design, I would say. I mean, like, this is something which we had been doing like for a while. We do a lot of facades now. I mean, we are heavily invested into a lot of doing and fabricating and executing a lot of facade projects. This is one of the ongoing projects. I just have a preliminary renders to show right now. This is an ongoing project in Rewari. It's a commercial center we're working on, where this facade is sort of simple yet has to be modular, because these are SCO plots which have to be sort of replicated. So the skin has to be such that any new development comes there sort of has to merge with that. So, and again, the same thing goes into the landscape as well, as a similar language. This is sort of an aerial view of the landscape. So you can see a lot of curvilinear languages, simple, straightforward geometry, yet having a sort of an elegance which was derived from the facade. So the landscape and the facade are sort of integrated in a manner where it has a very similar kind of a language, And then of course we are rationalizing every single aspect of it and detailing it out, how it has to be articulated. So just jumping across different scales. This is at the Bangalore airport, which we were a part of. This is a new terminal at Bangalore airport, and it has a lot of art installations. And so one of the artists we were working with, we were collaborating for, the artist had this design sort of finalized, and we had to rationalize the design using computational design. So on the right hand side of the screen, what you see as a detailing, this is exactly what we had to do and build all of these details into a parametric model. After doing that skywalk, I think this was a piece of cake for us, because it was of a smaller scale, and we build prototypes in the factory and sort of understand all the junctions and sort of rationalize all of that. This is a residential project ongoing, which we've been working on. But yeah, the behind the scenes of the projects that we work on is always sort of, be it any kind of project that we do. We are sketching. It's not only computers, it's not only the algorithms that we're working with, it's always a lot of hand sketches. You can see in some of these videos that we are kind of sketching it, putting it on the screen and stuff like that. So there's a lot of back and forth action that we play with the computer and the tools that we have. So we always see, computers and the softwares and the algorithms as a tool, as an extended version of our creativity. That's how we pretty much see it. We also have a venture called Art Lab, which looks into only art installations and sort of designing and building that. So just brushing through of a smaller scale. So this is what we do with a lot of interior designers. So we work with a lot of interior designers to sort of create a highlight space into their design spaces, be it residences, commercial, or whatever. This is a project where we were sort of took inspiration from a snake skin and sort of computed that into hexagons, of which all the angles are variable, and based on just light and how they reflect light, we could create an angular sort of an effect. And again, we had to do a lot of prototyping that we typically do on installations, understand the materiality at smaller scale, do a lot of CNC, and eventually we come up with this entire skin, which is actually made by multiple number of stone tiles which are put together. They're all CNC milled, numbered separately, and when they come together, they create this whole pattern only by the virtue of light falling and the angle. That's it. Of course, we had to really work with the toolkit, thickness, all these kind of aspects are something which we have to work with. So yeah, these are some photographs of the project. We love to delve into smaller scale furniture and these kind of installations. This is a small furniture piece, a small coffee table. So before we got on to creating that, we worked on materiality. We do a lot of sampling on MDF, which is simpler to do. Then we sample on the stone, and then thereby create these kind of geometries and forms which become a part of the product eventually. This was the chandelier I showed before as well. It's called chandelier R90. So basically you simply have a triangle which is rotated by a certain degree, and eventually it takes a 90-degree turn, the first and the last triangle. So we could add any number of triangles in between. The last triangle would be 90 degree. That was the whole idea and concept. And we actually created this into many projects that we've been working on. But the critical part was not just the design of the form, but the electrical wiring and how we can change the wiring when it fails. All of these kind of things had to be really worked out. So it's more of value engineering of a product at times that we have to do than just the the final output. This is being used in a particular space. This was another installation we did, and it was put in a hair salon. Again, smaller scale, different objects put at different angles, framed into an artistic object. We also worked on this installation of a Ganesha, where we sort of have this kind of a sectioning. This was from one of our recent projects where we had these, it was for a private jet company. We were making the office for that, so we created an art installation which is like the swooping metal planes, which is like a paper plane. and sort of creating an effect out of that. But again, like the detailing part becomes the interesting part where computation sort of helps you to understand the dimension of each element, the rotation, how to get that effect without actually changing the angles and stuff like that. And the whole process of fabrication, putting it on site is where the fun part happens. Now the second part of the presentation, I'll try to go really quick, I'm sure I've taken a lot of time. But the second part I want to talk about is the first part that you saw was the design by humans aided by technology. What you're going to see now is design by technology and aided by humans. So I'm kind of reversing the whole process. So all of the images that you would see next are designed by a computer. This is where we talk about designing by computers using artificial intelligence technology. Now AI technologies are created, designed, organized by human beings and not a computer. This is something that I really want to make a note of. So there are a lot of platforms which are platforms and programs which are very, very prominent and easy to use actually, which has its own problems as well, something probably we can take up in the panel discussion later. But what they end up producing, programs like Midjourney, I'm sure many of you would have heard of Midjourney. It's a very simple tool. You give it text prompts, it will give you an image. It's an image, it's not a space, it's not a design. However, we can use it to articulate in different manners. So it's a very experimental stage of the technology, I would say, where AI has started to become mainstream. All of these images and spaces, what you see, are basically 2D images which are created using AI by text prompts. I'm just going to quickly brush through these images, nothing much to explain through that. These are some of the works of our tutors. I also run a 6-month program called Smart Labs, where we train architects and designers about design technology, and we've recently added AI into the curriculum of that. And this is the works of one of the tutors, which was taught to the students, the entire workflow and the process of how to get multiple iterations of spaces, be it interiors or architecture or facade. This is fluid Hindu temple. This is all created by computer, only by a text prompt, So, and these are works of some of my students from Smart Labs who actually tried to fuse computational design and artificial intelligence into a system where we can form a systemic process where we created these iterations and we sort of modeled parts of that using parametric techniques. So basically, this is something very experimental right now, but I really wanted to show it. And so we started with text prompts, created these kind of spaces, and that was articulated as 3D model. The bottom right image that you see is actually a 3D print of that image. But AI does not create a 3-dimensional object. So this is the process that we had to really intervene in as a designer, that how do we operate between AI and computation to create these kind of effects. This is all modeled using computational techniques, but initiated by AI. This was a temple space project. And after creating iterations, we really what we teach to our students to really fine-tune different elements, how to model them, how to compute them, how to use and leverage the computational and parametric design processes and sort of develop something out of it. So AI is not just like as a final output, but AI is the starting point of designing something, is how we are currently experimenting with it as. So these are some of the visuals of the output from the workshops. This is all student work who had zero exposure to parametric or computational design before they were a part of the program. And this is all like how they were computing things and stuff. So this is something really interesting, and again, we are taking that forward into various kind of workshops and programs as well. And again, so AI of course has a lot of possibilities, a lot of iteration. These are like referenced from one of the famous AI artists. There is a lot that one can do using AI. These are like all computer generated. These are not like human generated, but prompted by humans. But how we prompt and what instructions we give to AI is something also which needs to be developed and educated upon. So yeah, a lot of fun stuff to see what AI can do actually. Can you get the audio on this, if we have? Okay, so at the end I just want to show you this video.
The Faroe Islands are an archipelago of 18 islands located in the middle of the vast North Atlantic Ocean. Its isolation meant history's greatest artists never had the chance to visit. But can you imagine how Van Gogh would have painted this? Or how Claude Monet would have painted this? A computer can. By using artificial intelligence to analyze billions of pictures, the computer can learn to understand shapes, colors, and the personal style adopted by some of the greatest artists ever known. The computer can create new pictures of the Faroe Islands, just as individual artists might have done in their own style. A carefully curated collection inspired by some of the greatest artists ever living will go on display at the National Gallery of the Faroe Islands at an exhibition opening on the 29th of September. At the exhibition, the audience will also get a chance to create their own images using artificial intelligence. The exhibition raises interesting questions about what art is, what computers may do in the future, and even how Picasso might have represented the Faroe Islands had he been able to travel to see the country. Can you imagine?
So yeah, this is just a thought-provoking video at the end. Let's say hello to the future. AI is here in the art industry. It is there in architecture. So I wish all the best to all the architects to cope up with AI. That's the thing that we have to do now. So yeah, so that's all about us and what we do. Yeah, we can take up any questions later, perhaps. Yeah, thank you.
That was a brilliant presentation by architect Sushant Verma, very informative and very educational. I saw similarity in one of your project, the temple project. It reminded me of the Sagrada de Familia by architect Gaudi, and he built in the 18th century that Sagrada de Familia. And I wonder how he must have conceptualized that design and executed it. It's very easy in today's generation with all these math and computation techniques to execute and the 3D printers and all. But in that age, it would have been, it's simply unbelievable how he conceptualized and brought that into reality. So may I call Mr. Mukesh Agarwal to introduce our next speaker, Sridhar Mamidala from Hyderabad.
Good evening, everyone. Architect Sridhar Mamidala, Principal Architect at Sri Design Lab, is a respected computational designer in India and has a decade of experience in product design, interiors, artifacts, and computational art. His intuitive approach to design uses emergent computing methods with a focus on machine learning and artificial intelligence in architecture and design. Sridhar's work explores complex geometries and draws from synthetic biology and digital fabrication techniques. He has designed parametric furniture, art installations, and is also active in teaching. Welcome architect Sridhar Mamidala with a resounding applause, everyone. Stage is all yours.
Thank you, Abid, for having me here. So Kolkata is very special for me. My hero comes from here, Sir Bhagat Singh, Sir Chandra Bose, and I was very happy to see the airport named after him. And also, it's an amazing opportunity to meet my friend Monish, I think after a couple of years. So let me dive into the presentation. So my presentation is called Patterns. So recently I was scrolling Instagram and Jordan B. Peterson, who is irrelevant to design, said this, that people think that the purpose of memory is to remember the past, and that's not the purpose. The purpose of memory is to extract out the patterns from the past lessons and to structure the future. So what I'm trying to say is memory serves as a crucial role in human cognition. It helps in storing and retaining the memories. And why it is important is memory helps in learning from the past events, making better decisions, adapting to new situations. It also plays a significant role in forming our identity and personality. And it also helps in sharing experiences and knowledge over time. And this is how tools are also have been developed. So we'll be transitioning from something very physical to very digital in the presentation further. So when it comes to pattern forming, on the other hand, is a fundamental cognitive process that involves recognizing and understanding the regularities and the trends, which is informative. And both the memory and pattern, these things work together in the human mind, forming the integral human cognition, allowing us to navigate the complexities of the life. So this is our Earth, blue planet, 70% surface, 71% water and almost 30% land. And we can say life has been around 4.1 billion years theoretically. And this is a transition from the 4 million years of tool making as animals. So 2.8 billion years ago, humans started using stone tools. And before that, nothing much happened actually. And then came fire, and then we started cooking this raw things, and then nutrition, etc., started supplying to our heads. Like carbohydrates started absorbing into our heads. That is how we started thinking much. And then you can see, there's just this hunter-gatherer thing. You just wake up, you hunt, you sleep, and you find yourself lucky if you're not, you survive the other day. So your whole day, your whole life is all this. But once, tools started happening, people started taking roles into the society. So this happened around like 300,000 years of human history, from the hunter-gatherer to, people started allotting, the specific roles into their society, like say carpenters, artists, rulers, etc. So it's only like 50,000 years ago, tools and civilization started. So we see an exponential growth. I'll just show you the graph also where you see an exponential growth in human development. So in the past 10,000 years, human entered the agricultural age. So here what's happening is from the hunter-gatherer mindset, now you have that mindset of, allotting a particular time of the year where you can get your yielding. And then the other part of the year, you're completely free. So this free time gives you time to create tools, which again, it's like a visual cycle, help you in further development, say in like wise economy or development or the complete evolution of the human societies. So modern society is not very ancient actually, it's just like 500 years ago. So people started observing nature, etc. So this happened because, we came from this hunter-gatherer mindset, and then we started having agricultural lands, etc. Roles have been allotted. So there was also some people who were very fascinated by nature and math, and then they started noting, documenting, understanding nature. So that's how modern knowledge has been subdivided again, like math, biology, physics, chemistry. These things came into existence. And this now from there, using all this advancements, we entered the industrial age, where there was a huge economical boost, a huge transition, breakthroughs, etc. Everything happened in this era. And then after that, from the analog things, we just entered into the digital age. So computer being the most important tool here. So all the shift came from the mechanical worlds to the digital worlds now. So why is this important? You can see this bar, maybe you cannot read the text, but you can see only the last yellow thing, that is where the major development has happened. You see this pattern every time the timeline is decreasing. Here what I'm trying to say is tools have been invented and then we are going just exponential. Like also if you have noticed, we've been talking about computational design a decade ago and now we're talking about AI. I don't know what we'll be talking about tomorrow. And why these things are important is, as you can see this timeline here, there's a clear correlation between technology and art and architecture. So technology always governs art and architecture. So I don't like people, seeing it as a very alien technology. Math has always existed, always governed us, and this is the proof. And we'll also see economies also as well. So this is like a visual cycle. There is a superstructure in the base, where social and economical structure are determined by art and culture. And culture is simply an expression of whatever the economical seat is in the driver's seat. So however, culture, etc. Like for example, there is culture of partying, etc. So where do we get this time? I mean, we have these tools which have simplified our lives. And then we have this free time to party or, have leisure activities. So this is how technology is related with economy and then culture and our cultural behavior, practices, habits, and further evolution. So an iPhone is a very good example of how art and technology have merged together. And you can see a great boost in economy, and then you can also see it's become a very norm to see an iPhone everywhere. Everybody is having an iPhone worth around $1 lakh or $2 lakh. So you see so much of technological advancements, and that is how it's also improving the economy as well. So I'll be talking about 3 different relations between art and technology. Art that uses and explores specific technologies, say art or music. And then there is art that responds to issues raised by technological changes. So what I'm trying to say is here is that art is trying to see the problems which have arisen by technology and maybe coming up with another alternative, or going back or reviving some other art forms again. And there is another relation where art that exemplifies the dominant technological paradigms of the time. So what I'm trying to say here is art is extensively used along with technology to express deliberately the kind of technological paradigms we are in, pushing to the extreme limits. So math, this might seem very irrelevant, but math is just noticing certain patterns, like we spoke about patterns earlier and tool making. So math is just a study, noticing, describing, generalizing of some patterns, also quantifying them. So any natural behavior can be put down into a formula, like say for example, you're talking about computational fluid dynamics, how liquids behave, etc. So there is an algorithm to express these things. So you can calculate the strength of materials, etc. So everything, every natural behavior we can today quantify as math. So as I said, computation is not something very alien to humans. It's just an observation, and math has always been in nature. So I'm just showing you a small example from a video which I picked up from YouTube. So this is this number sequence which is observed in many cultures, but popularly known as Fibonacci series or Fibonacci sequence. So something like this can be expressed as a sine and cos multiplication of a number sequence. So another example that, math is not something we have invented. It has always existed in nature. We're just observing it and documenting it and sharing it to further generations so that we can study more and get more out of it. So these are some of the popular patterns architects are using nowadays, calling it biomimicry. So the pattern which you saw was called phyllotaxy. Yeah, the elements in between. So that's called phyllotaxy. This is called Delaunay triangulation. This might seem irrelevant, but once you take it and turn it into 90 degrees, you know, all the segments, this pattern is called Voronoi. So you see this everywhere, dragon wings, the cracks on your skin, stones breaking, walls breaking. So nature finds the shortest path to break, and then all these elements are called Voronoi, maybe in a 2D or a 3D form. So why this is important is, like I spoke about this understanding of numbers and systems, you can see this ancient civilizations just used, just this Fibonacci kind of sequence. Maybe they didn't call it Fibonacci sequence, but it was majorly based on the human body and proportions. Like you see the pillars, it's like, if you consider this as a human height, the top part of the pillar, the abacus would be exactly proportionate, which is like 1/8 of the human head. So here again, maybe there are no computers, but there is numbers again involved in architecture and shaping architecture. And quickly moving to Gothic architecture, you see the proportions, the way of calculating, the proportions have changed because math has improved. So there are certain segments of math which has involved, and designers took use of these the math in shaping new kind of architecture. So that's why you see a very drastic change. And now we'll be talking about passive versus computation. One of the major inventions in getting this very organic forms is subdivision algorithms, or another similar technology is called NURBS. So this is a modern car, but again, around I think in the 60s, 70s and 80s, you might be seeing cars like this with this kind of edges. So that was like a design constraint. But again, after you see, there is NURBS and subdivision modeling, which helps in creating very organic Bugatti car kind of a design. So I'll explain you what exactly is happening. So there is this primitive geometry, and we just keep subdividing, and then after a certain process, it turns out to be completely different shape. It starts looking very organic. So here is one of the prime examples where I just made a small module to explain you what exactly is happening. You might be seeing this like, this might be resembling much like Daniel Libeskind's work, very sharp, pointed, edgy. But again, if I run an algorithm, it turns out something very Zaha Hadid-ish. See, it's the same module, but just one algorithm changed the entire design language. So unfortunately, architects don't have our own tools, so we borrow tools heavily from other industries. This is one example from the animation industry, Maya, where people don't do the complete expression, they just do the first and the second, and then everything in between is created automatically. So I'm just showing you a small example, basically, where I just created two curves, and then maybe I can consider this one as parent A and parent B, and then I can expect a offspring which shares similar attributes of both the curves. So what I'm trying to show here is I'm not creating entity, I'm just creating those two things, and then everything in between is being created with the algorithm. This is like a 3D version of it. So what I'm trying to show here is with computation, number crunching has become very fast and it's become very easy, such that every tiny MMs I can create a different surface. And then I don't like the term parametric architecture. I think the word parametric architecture was first coined by Patrick Schumacher of Zahadid Architects. So I do appreciate Zahadid Architects, but not a huge fan. I don't follow them much. But I would like to call this architectural style or approach now as computational design, because the complete breakthrough has happened only with computers. So there is only parametric modeling and not parametric architecture. So this is one of the examples on how these things work. So what's happening in this trend is people are not creating models, they're creating a system. So not just an object, but a system where you can tweak parameters and then you can get a lot of variations in it. Okay, so these are some of the projects. So this is like a personal project. We wanted to do something different, not just slices or 3D printing. So so I often see people studying abroad and ending up in India, and then they want to do something different, and they keep complaining that they don't have access to expensive machinery. So this is one example where you can do something different even without machines. So there is this generative aspect of computational design where you just create systems where you can create multiple options out of it. Let me show an example. So here you see a similar design language. They share a common design language, but they're not same. Something like the human face. We all have ears, eyes, and nose, but slight proportion makes a completely different individual. So we were working with a shoe company. Stages we were creating this abstract algorithms based on performance. So just to explain them the possibilities, we just created a simple algorithm again. And then we were working with a jewelry company back then in 2019, I guess, if I'm not wrong. So to show them the potential of computational design, we created this small system. I'll show you the end result. So this is just like a very primitive thing. And then there is this emergent aspect of computational design where what happens is you create systems. You have a rough idea about what the design would be, but you don't have a very clear idea of the product exactly, like how it turned out to be. Like here I created an algorithm where it will be mimicking something like a brain growth or a fingerprint pattern. I know how the pattern would look like, but it's not easy to, maybe draw or something like that, to predict what I'm trying to say is. So biology-inspired algorithms again. So with that, we came up with this and this. So these are some of the examples of generative algorithm. What is happening is I just programmed some patterns to follow certain rules here. So the math is same with a slight change in parameters. The complete design language is changing, you can notice. So again, I'm trying to say that math is shaping architecture and design and art again. So all these things are the same algorithm. And then there is algorithm. What we're talking about is like algorithmic architecture also. So people are not creating products, but systems. So this is one example of algorithm architecture. So I just created a basic spiral, just multiplying a number range with sine and cos. That's it, simple. And then there is something called procedural aspect of the computational design where platforms like Houdini, you're just using a process of design. There is evolutionary architecture also. I mean, it's a part of computational design again. So nature inspired. So this is a small algorithm explaining how the solutions can be formed. So I have this small word called evolve. So I already know the solution. I'm just cross-checking the algorithm. So you can see the sliders are being controlled by the algorithm to reach this destination in a very short way. So sometimes the design solutions are not just averages. Like say, for example, I'm designing a building where I want to get beautiful views of Kolkata, major points. So I can create something like this algorithm so the building twists in such a way that I can get, economical construction, yet beautiful views also. And then you can also call it digital architecture because everything has to do with ones and zeros and computation. So I think something like computational, this term engulfs everything, like say parametric architecture. So computation is the exact term. So let me just go through again: parametric, generative, emergent, algorithmic, procedural, evolutionary, digital, and computational. So computational is the best term. And about our practice, these are the tools which we use. As I said, unfortunately, there are no certain tools exactly designed for architects. So we just use tools from other industries and disciplines. So this is one of the major projects which we completed 2 years ago around December. So this is like a gaming center, and we wanted to create something very different, and this was the first projects where we had full freedom. The client didn't know what was about to happen actually. So we just had a strict budget in hand, and he wanted to have something amazing, that's it. So we completely avoided plywood, etc. So there is no plywood, no traditional materials here. So all you're seeing is 3D printed parts, some steel, and fiberglass reinforced plastics. So the way architecture is performed today is also very different because, as I said, we borrowed different technologies from different different industries. So this is one of the prime examples where you can see, things are very different. Once you start using a different mindset into, designing and in production, so results turn out to be something like this. So these are not just fancy; these are load-bearing structures also. So around I think 6 to 8 people can sit on this comfortably. And it's like super light also as well. And the wall thickness is just like 3 to 4 mm, that's it. So material play again. So this particular chair, I think I showed you earlier, this is made of paper. And this can take around 300 kgs easily. So this is like a recent project again. So we were trying new materials like NFC and HDHMR. So this is very academic and very technical. So I think it's better I stop here. So let me conclude this. So computation is happening on very different scales now. On the cellular level also it's happening. The same thing what computer is doing, the cell is also doing the same thing. So it's carrying information, it's processing it, it's sharing again, it's multiplying. So it's like two different scale of the worlds. Reflecting the deep contemplation, you can understand that there's both similarities. And there is a lot of they share something common like the complexity, order, cycles of life, adaptation and evolution, harmony and balance. So these comparisons should encourage us to have this philosophical inquiries into the fundamental nature of life and the cosmos. Yeah, thank you. That's very much it.
Thank you, Architect Sridhar, for that wonderful presentation. We are honored to have with us today esteemed experts from the field of architecture and design. Their wealth of knowledge and experience has greatly contributed to the advancements we see in sustainable design practices. That's exactly the topic for today's discussion, parametrics for sustainable future. Ladies and gentlemen, please welcome Architect J.P. Agarwal. Architect J.P. Agarwal is the founder principal for Agarwal and Agarwal Architects. May I now invite Architect Kamal Periwal, principal founder of Maheshwari and Associates. Architect Sushant Verma. May I call upon stage architect Manish Rirapuro. Architect Sridhar Mamidala. Please welcome our moderator for today, Architect Vivek Singh Rathore, Principal Founder, Salient Design Studio. He'll be guiding us through today's insightful discussion. Stage is all yours. Mic, please. Can we have the collar mics and the cordless mics, please?
Namaskar. So we have quite computed the understanding for the evening in terms of parametrics, right? So first, it was a good presentation by Sridhar, Manish, and Sushant. Quite enjoyed. I came in when Manish was really talking very critical about the temperature. How do you manage the microclimate, passive climate? So friends, you know, the purpose of this is how do we compute business fast? Is that what it is? How do, no. Is we change. The reason of this panel discussion, I was actually thinking, sab fatafat ho raha hai, things are happening so fast. The question should be, boss, this is my business parameters, batao aage kaise karna hai, fatafat. So give that feedback and you get the fastest business. I mean it sincerely. Because in the future, what is happening is, we are, I will break in, Sridhar, you're fine with Hindi, right? Yeah, perfect. I'm sure that you guys are. एक मुंबई हर साल पैदा करना है, हमको नहीं करना है, देश कर रहा है. One Mumbai every year, India is going to produce. अब आप सोचिए कितना ज़्यादा construction, furniture, decor और consumption of resource होने वाला है. Now that is a kind of huge amount of pressure that we have today. So obviously we are not prepared for it. Till the jo ab tak karte aaye hain, whatever we have been doing till now, we have not been equipped enough to handle that pressure. So we will bound that we will make mistakes. We are making mistakes. हो सकता है कि mistakes ज़्यादा ना हो जाए, उससे बचना है. Is it okay to understand? I'm being very candid and sincere in my apology. We should not make more problems with us and for others than actually trying to make something wonderful. In the past, computational processing, or if I can use the word better understood is right now, is parametrics, makes it easy to handle this pressure. If it can make it easy to handle this pressure, तब तो बात बनती है, वरना तो जैसे चलना वैसे चलेगा. I think that the purpose of this discussion is, can we see this skill set, this knowledge, this approach, or this aid in design to make us more resilient, robust, and sustainable future? So I'm just making the understanding clear, and we will go very fast in discussion, more of a question. We will ask, and be free to ask. Koi question ye log bechare, you know, there were 3 speakers. I'm sure everybody's saying go fast, go fast. We'll make it 15 minutes of discussion. And when I saw the panel, I was quite excited because I see someone like JPG who has spent a lot of time both handling volume, quality, delivery time, many metrics to handle a design. Agreed? And then we have, I was just asking that who has got this furniture done? It looks interesting, a little different. Who is made here? So he said someone whom I'll meet after this talk. It looked nice. My question is, does it behave nice? Can it be reproduced faster? Is it consuming more material? What is going to be price of it? Is it affordable? If at all it makes to be. There are so many other parameters. Bhi question aate hain. So Burj is here, and this is where I will start the thing. Like, and my question here is, oh, I was all the while. This sounds better. All the while, my question here is first to Manish. I quite like your sensitivity towards making a more resilient, responsive design. You've used parametrics. It is not just skin deep. You know, it's not a skin. It's going much deeper. And that's what made us, or made me really prompt this question to you is, have you computed and analyzed sincerely till now in your practice, what would be the best way to consume less in your design? I'm sure that you have computed how to get more in terms of like daylight, etc. But have you ever computed being less?
Absolutely.
Yeah.
And I think this is very thought-provoking, your introduction to the whole, I mean, what you just said right now. So before answering this, let's not confuse parametrics with economics and data. I think these are the two essential parameters, I would call them as parameters, that are missing in our practice. Because when we say economics of scale, economics of carbon, economics of consumption, what we're talking about, when we start looking at those numbers, which we typically do not discuss, that's when we start getting the right answers. And which also comes to the second question, what you're talking about, which is about the consumption part of it. So the first, like the project that I showed today, which is on the residence that we did using the Anahat project, like I said, it also reflects back on the consumption economics as well, and also the cost. Everything boils down to that. And the first time we did the whole roof, it was roughly about 8,000 square feet. And after optimizing and everything, we tried to bring it down. And overall thing, we tried to bring it, to make the whole project possible, we got it down to 5,250 square feet. Maintaining the same essence in the design, and also trying to see how we can fit and how do we optimize the whole overall thing, but without really compromising on the essence of what visually it is looking like. And similarly, I think that these are some of the parameters, like I said, when we look at a design from a very visual perspective, what it catches the eye, I think that's the first thing that attracts people, attracts the attention. And what computation can actually do is this optimization, and which comes with analysis. And first level of this computational design is analyzing what is already there. And the second step to that is optimizing what we have already done to formulate the final result in the design.
Okay. So good, he says yes to that, and we'll go into figure. Maybe out of this stage we can discuss more of the figures. Everybody's free to discuss. Sridhar, tell me one thing. You showed the furniture, which is
Yes.
For a gaming studio. Is it something like that? That furniture from a gaming studio, I expect so. You
Hello.
there?
Yeah, it was in Hyderabad airport.
Sorry?
It was in the Hyderabad airport exit.
Hyderabad airport. Okay. So we often come across to a requirement of time. Time.
Time, yeah.
So, giving an example, if you didn't have the tool that you have now, and you would go the regular way, can you make us all understand that is it advantageous for you? Is it an advantage for you to use this tool and you could do things faster or manage the client better? Obviously, I understand that you got more iterations very fast.
Right.
Having said this one, did you ever try the conventional approach, or were you schooled to always go to the regular approach, the approach that you're going, the computation approach?
You mean the mainstream approach to the project or the mainstream architecture itself?
The mainstream design, whatever, furniture design you're doing.
Okay.
So in that case, your time management, was it much more smarter using the tool?
Okay.
Or was it that you could come with more iterations to actually show an options? Was that the advantage? What was the advantage?
Okay, so...
Or both, maybe.
Okay, so also being an architect, I'm also fascinated with geopolitics, material sciences again, and economics also deeply. As you can see, my presentation was all about that.
Yes, yes.
And
Very
as
nice.
you were talking to Monish, so I noted that, China is being grey listed, and then India is becoming the next marketing, hub. So I think architects should focus here also as well. The other day I and Monish were talking about the same thing, like how architects can scale their business actually. So when you're talking about computational design, it's not just about design. it's also about computers being involved in fabrication. Like, say for example, 3D printers, it's
Right.
a small computer again with a fabrication unit.
Sure.
So when you're talking about a robotic fabrication again, computers are again involved there. So what I'm trying to say is computation just doesn't stop just with design. So what's happening here is it also becomes easy to automate as well. So as an architect, I think I'm just changing my face, I'm changing my directions to become more like an entrepreneur where I can scale systems, as you were just talking about. So things like 3D printing, etc., these kind of systems help change, the course of architecture.
So I get your point that, what I'm getting that yes, I'm using the word yes, it helps us to make better sense of time and delivery because you can get smart modular. Fatafat modular ban sakta. I can get modular, I can get complex modular also, and also my machine aided manufacturing, let's say it's as an architect prefab or it's a 3D printing. Okay, only 7 days back, we were there doing something with Universal Studios and trying to see how can we make them a difficult, the roller coaster, but yet make it human. So I was there to make it human. Okay. So and then it was fun to know that they are trying to see everything done in the 3D printing. So I can buy your point there that if we use a smart manufacturing technology, then this is the best, fastest, and the most clean cut. So you don't let's say you do the prototyping, but the prototyping time gets saved. A lot of time gets saved there.
Yeah. So let me cut you there. So one benefit is that once you put this objects into, the slicing algorithms into, the further process for 3D printing or CAD manufacturing, you get very precise time of fabrication. So less human intervention, things happen, everything on time. Like say, for example, you're dealing with a carpenter, many things can go wrong, the weather can go wrong, his mood might go wrong, anything wrong can happen with his family. So there's typical problems which we face in the mainstream architecture. What happens with machines is you can automate these things, you can scale these things, and then you can give a precise delivery date to the client.
Beautiful. I think that sums up the point. Now, Shushant, just tell me one thing. You have what I understand that you showed that illumination design, that chandelier design, which can be propagated or can be added and grown and things like this, which is good. So I'm just making it very clear and fast. Having in your practice all the while, was there a big question asked that is your technology that you're employing, does it make the product or the output affordable to the market? Or no, you are equally costly or equally affordable compared to the other one. So giving as a value to the customer when it comes down to exactly in terms of purchasing, buying or acquiring, does the technology help you to give a really value in terms of money?
Okay, so I'll get to the answer to that, but before that I want to touch upon, the starting part of the dialogue that you started with, that can technology do this also? Is it smarter than the other? So this is something very deeply, I feel deeply concerned about this whole perception about technology, that any technology, we carry so much of burden to prove whether the technology is better than the previously existed technologies or not. That sort of impacts the way we use technology as well. And I'm sure there are people who are using technology here would sort of may be able to relate to that as well, that every time we use a technology, we have to prove that, is it also smart? You pointed out that in the furniture also. Is it also affordable? Now that question starts because there is a perception that this is going to be more expensive than a regularly designed furniture. That question should not come in the first place, ideally. It does, of course. To us also, it's a very human nature. Same thing happens with the designs that we do as well. And I think I have come to a stage of, I've stopped fighting it out to prove why this design is smarter also, is better also, is cheaper also, is more cost effective also, is more environmentally conscious also. Did we question all of these things when this technology did not exist? Did we ever question that the kind of architecture or design that we're doing, is it also solving the problems of the society? Is it also solving the problems of economics? You design a hospital, nobody asks the designer that, does it also heal the patients? But if I design it using parametric design, that question will definitely be asked. That can it also help in healing the patients, you know? So it's a very bizarre kind of a narrative that we have actually built over a period of time around technology. And this is not something very widely spoken about. So, in fact, in one of my upcoming books, I have this whole chapter which is called Why Architects Hate Technology. And it's more of in a more sarcastic way written, because we always fear technology. That's the fact, because technology moves so fast that we are always trying to catch up with the technology, trying to learn and trying to make ourselves better than the technology. So the first question comes that why computer? Why not sketching? You know, same question we never asked the same question was asked when we started to use AutoCAD, for example. Same question is now asked, why AI? You know, why not non-AI generated designs? So this thing will obviously happen with any advent of new technologies as well. So yeah, that's just something which deeply concerns me as how we look at technology. And I think we should neutralize the way we look at technology, that it is just a tool, it is an asset available to us. You use it smartly, you use it not so smartly, it's really up to you. At the end of the day, what matters to me is what designs I'm doing. You know, so there is a philosophy involved, there is a process involved always, which keeps on changing over a period of time. Sorry, I'm extending this question a little bit, but coming to the point of that chandelier, yes, we also feel that burden that every time we design something which is unusual, we have to prove that it has to be better than the conventional, cheaper than the conventional. So yes, we do factor in not just in that product, but also in facades when we do. We do factor in, okay, if CNC is going to be used, how much is it going to cost? Then we do a comparison that whether we do and this comparison we have to show to the client. If we do a normal DGU versus a curvilinear metal facade, this is the difference in cost. And to be honest, 99% of times we try to come lower than the cost of the conventional system. That is a burden we have, so we have to work towards that.
Very true. So what? This is a very important point, which actually trying to provoke and make a point understood. There's every technology. That's what we look forward to. And I'm giving you one small example. I was started in saying, you see the diagrid structure which is next to this building, the Milan Mela, which is holding the globe above. With the conventional way, it was 6.5 times more steel. So when it became a diagrid structure, which is obviously it's more parameters to evaluate, the consumption was almost, as I told you, 7 times 1/7. And that's the reason you see that entire thing is very light and was again made in India. So the idea was that when we wanted to redesign the entire stuff, so the guy said, will it stand the entire thing? Will it stand? But one has to just say that yes, it will stand. It doesn't need so much of steel. And still standing, stands very well. So see, any technology, which is a point which is Sushant said, I really want to harp on this, that you have a technology, over the time, it will prove whether it's resilient or not. Or a technology is a dynamic culture, it will keep on improving itself. And that is what it is, it's responsive. So the idea is that we often get set back, you know, I'm maybe not using it, it's expensive, or whether it is, whether I can do or not, or whether it's needed or not, or maybe I said, this is not needed, boss, it's not needed. And that's the reason we need to weigh it all together. It has to be weighed in all levels to understand, and because it also needs to be improving. So my question to you is now coming to the grand practices which you have, and my question here is to JPG, that looking at what we have in demand, जैसे एक मुंबई हम लोग को चाहिए, हमें चाहिए मतलब हमको करना ही पड़ेगा अगर हम participate करेंगे तो, and I'm here asking as an architect to you, how much today, your practice is almost 40 years now? Yeah. So clap for him, 40 years of practice. No. It is not easy to 40 years of a robust practice, and you must be seeing people coming in, technology change हो रही है, आपके ऑफिस में नए लोग आ रहे हैं, कैसे आ रहे हैं? What do you think does not change? जो it's important to understand today, and how much of inclusion, and since it's topical, so I'm putting how much of inclusion of this what you're talking about parametrics, should we include in our present approach? हमें लाना चाहिए, तो और कहाँ तक लाना चाहिए ये भी जानना है. So let's.
I think I got a very simple answer of your question.
जी.
That suppose you are designing an office and you got a reception table to design. And of course, you want to make a statement out of the reception table. So you can afford to spend and you can design in a very flamboyant manner. But if I ask you to design 200 workstations inside in the same flamboyant manner, in the same parametric manner, or in a curvilinear manner, can you do that? The answer is straight no, because it will not be space effective. If at all you try to do that kind of a design, it may and may not be space effective. My dear friend may not agree with me, but I can say that the geometry, the straight, simple geometry will always give you more space efficiency than the curvilinear linear space and the divisions made out of that. And there are so many side effects of that. You know, I'm not getting into it. The question is that when you are talking about addition of one Mumbai in every year, you must understand what it is. Is it out of the population growth? Then nowadays the answer would be no, because we have reached to a stage where growth has reduced, but our economy is growing. So the best part of India is that our economy is growing because of the MIG is growing. The LIG is converting it into the MIG. So that is the best part of India. And whenever I see or observe the kind of a housing complex we make, and what earlier it used to be, and in practically every housing complex has at least 500 houses. And nowadays the people have got an aspiration to do the interior something, कि हाँ थोड़ा तो interior करके घर में जाएंगे. And when I look at that volume, the number of houses being made, I remember when I came to Calcutta, I had a project of 40,000 square feet in Tollygunge and about 55,000 square feet on a Gurfadai road. And these two were considered a very big project. And when I got my first housing complex project, that was Club Town, that was about 3.5 lakh square feet. Arey baap re baap, kya project hai? Matlab, such a big project. Then we got first IT park, Infinity, that was again around 4 lakh square feet. And the later on, the IT parks which we did are about 25 lakh square feet. So you can imagine the volume which has come up. And this volume has not come up because, builders wanted to do it. That growth has come because the economy has grown and we require the space, right? So now, if at all we look at our responsibility as an architects, that where do we stand in this particular growth of our country? And when we talk about the, contributing it to the society or contributing to the Mother Earth by going net zero, etc., etc. Let's be honest. The problem is that हम लोग को कुछ भी बोल के निकल जाता है. That is the problem. When you talk about the net zero, we must understand what the bloody net zero is all about. When you're talking about the carbon neutral world, you must understand what the carbon neutral world is. Are we ready to look at that? Are we really honest for that? So coming back to the role of parametric designs over here, that of course, everything in nature is parametric. ऐसा कोई चीज ही नहीं है जो पैरामीट्रिक नेचर में नहीं है. मतलब if you look at each and every person seated over here, we are the product of parametric. एक दिन भगवान ने एक फेस बना दिया, उस फेस से मल्टीप्लाई हो गए. And we see, if you look at my brother, he is similar to me. But maybe 20 generations back, मेरे कोई grandfather के भाई होंगे, वो वहाँ से निकल के वो अलग हो गए. That is the parametric. But let's remember Buckman Fuller, let's remember Euro-Saranian. And let's see the old buildings, the design on the parametric pattern like Opera House, John Kennedy Airport in New York, the arch designed by Euro-Saranian. What these projects were? They were designed without grasshopper. It never required a computer or anything like that. But they made best use of logic in doing so. So, are we looking at parametric use for the aesthetics, for the variety? Because of course, we all want variety, we all look for an aesthetics. Many will not kharab koi baat hai. But the question is that, are we making logical use of it? When we look about the net zero, do we have a understanding of what kind of a carbon is produced in the plywood factory, or for that reason, any material used in our construction. The building industry is the second largest carbon producing entity over in the world after the transport. And do we understand that the carbon produced by us remains in the outer surface of the earth for millions of years? You know, it cannot be eliminated so easily. And that is the reason the ozone layer harm and all this temperature problem has arisen. So now let's look at the very simple example कि 8 फुट by 4 फुट का एक plywood का sheet, उसमें से मैं एक parametric design से मैं एक table बनाना चाहता हूँ. How much plywood will be wasted? Give me the answer of that. और उसी से मैं एकदम simple when I say the calculate एक line 4-4 इंच 4-6 इंच में निकाल के बोलूँ यार मेरा 1 square feet waste नहीं होना चाहिए. My developer will come and tell me मेरा tile ऐसे लगाना भाई कि 5% से ज़्यादा wastage नहीं होना चाहिए. And one fine day, if I come up with a parametric design and do the CNC cut on the tiles, I'm bound to waste 30%. So are we logical in doing that? Are we answerable to that 30% wastage? In electricity, there is something called electricity audit. In the mall, if you use extra electricity, आप CSC को क्या pay करते हो वो मतलब नहीं है. Whether you are using efficiently or not.
Shapes. But frankly speaking, yes, while shape generation comes, the response for the shape is the best thing for why it's coming. So the computations becomes more easy, and if I can apply into material resourcing or material, let's say plywood se aapne baat kiya, yes, one can use the tool to create the brilliant support his concern, and I support the double concern to use the tool. And I'm saying that we should, that's what should be coming from. Now, Kamal bhai, tell me, you have a second generation, your son is also there in the thing, right? He's working with you? Yes? Yeah. And there is a generation gap and generation stitch. That there is a, like Bauhaus still continuing, and then there is a, let's say, an influence by shoemaker, or let's say, fluid shapes, etc. Right? That's it, because the tools have changed and visualization become very easy. Where are you landing right now? Where are you landing?
Yes, we are working hand to hand, and there's no issue arising. Yeah.
So you are inclusive. You're saying that we should include.
Yeah. Yes.
Correct. Now, have you ever tried to use this? Now, have you ever tried to use this? As he said, wastage. 40% wastage generate hota hai. Hum log, why don't we start thinking, or if we start thinking, you also have a very robust practice, that using the waste, and I'm sure that यहाँ पर जितने लोग हैं, काफी लोग manufacturing, मतलब most of us in manufacturing, I think 30-40% manufacturing में होंगे यहाँ पर जो लोग जो background से हैं, तो जो waste produce हो रहा है, I'm just saying the waste which our industry is producing, that can be effectively used. I'm giving an example also. I recently forwarded one little video, it came talking to me from the Green Center, was that they are using AI timber. So normally हम लोग जो लकड़ी काटते हैं वो rectangle फट्टे में बना देते हैं तो edges निकल जाते हैं, चाहे वो टुकड़ों में निकलते हैं, बाद में ply में use करते हैं या फिर threaded में use करते हैं, then we press it on. But we want rectangle planks, and then we can stitch them together to make a larger sheet. I'm talking about timber, large volume timber. What they have done is they've mapped the entire stuff, all the odd shapes of the wood without even taking the edges, and they used AI aided gripping or stitching, the numbering, and they saved a lot of energy. They saved 16% of the energy, and they saved 80% of the wastage. तमीज से यूज किया, मतलब आपके टर्म्स में लॉजिकली यूज किया तो, एंड इट लुक लाइक ए स्टैंडर्ड प्लैंक बट इट वाज स्टिच्ड टेढ़े मेढ़े जो है पोर्शन स्टिच होता है, दैट मींस 10 टाइप के प्लैंक्स के शेप को स्मार्टली स्कैन करके स्टिच कर दिया. व्हाट आई एम ट्राइंग टू से इज आई वांट यू टू टॉक अबाउट दिस. हाउ कैन वी हेल्प, और आई एम श्योर दैट सिंस यू सेड यस, द क्वेश्चन कम्स लाइक दैट, ऑफ वेस्ट मैनेजमेंट. इज देयर अ वे व्हिच यू कैन हेल्प understand this community who are also into manufacturing about waste management and the marriage of parametrics?
Very good question, Vivek. In fact, parametric design, we have some different different picture in our mind. That key, something which is fluid, something which is a lot of material used is the parametric design. But in my opinion, with the help of computerization, with the help of computer design, digital design, we can really save material. We can create some good designs. We can set the parameter what we are looking for. As such, as he presented that the client is looking for the Ferrari kind of house. So that was the mindset, and that is the reproduction of the design that he is satisfying the Ferrari kind of design of the house. But in suppose if we are, I'm using the wastage of wood log ka jo bhi wastage hai, in that wastage, if we have some material sizes and material things in hand, and we can create the computer parametric design out of it with the computer parameter set before time, and we can create design out of it, and it will be a very interesting product out of it. So there's no wastage question is arising. Again, the wastage which we can very much control from the parametric design is the urban design, where we are supposed to, as you are mentioning that we supposed to be architects, supposed to produce the one Mumbai every year. So that there's a lot of wastage can be saved with the parametric design, because you set the parameter and you get the computerization like that. So there's a lot of saving, there's a lot of thing we can create out of it. I think it is a very important thing which every architect or everyone should know, that it is not the only fluid design which you see. Of course, I will say that this podium which is designed by, I think, Art Collection, it is very good design, and it is attracting, and everything which we design for the attraction, that is what we are looking for. And of course, it is not the wastage of material. Of course, it is creating lot of attraction from the people who are seeing this podium. Or this is both way you can say. You can save material, you can create out of the wastage, you can create the product, and you can even sometimes you create object and you waste the material. That is in a controlled manner can be done.
Yeah, yes, please.
So computational design is a tool, and every time a tool is created, people find ways of using it in a different way. Say for example, you're talking about a blade. A surgeon can use it to save somebody's life. A robber can cut somebody's throat.
Very
so
true.
It's up to you. So based on your agendas, your time constraints, your budget constraints, I think many things can happen. Like for example, Moni showed like where he used the tiles, the leftover tiles, and then he created the sculpture. Yeah. So it's not always about wastage. It's also about your style also. Say for example, people do slicing a lot. So there's a lot of wastage in that. So it's sometimes that, the architect can create something better, but unfortunately the client wants something of that aesthetic style. So you have to go with it. But again, if there is a scope, I think.
So I think what it's quite interesting.
Vic, one second. As you said, that's a lot of furniture requirement is there for the mass people and all. With the parametric design, we can create the furniture which will save the material and which can produce a lot, like a multiple production can be done with the shape of the computer. Because if you see, sometimes you see that lectures are from the top to bottom it is round, but when you do the conventional system, it is all a square kind of thing. You can save material out of it, and you can have a less cost with the parametric design format.
Very true. And see, I'll add to this understanding. And in fact, ये हम लोग जो बना रहे हैं, चाहे वो carpet industry वाले हैं, or whether we are into manufacturing chairs, or even tablewares or decors, traditionally we are wasting almost 100% of our resource. 100%. जब काट के निकालते हैं तो waste हो जाता है. What I'm saying is, I think Sushant, you showed the combination of AI with AI. No. See, and this is where I'm again giving an example. I was in FIND, FIND, which is a design fair, Asia, and there were at least five stalls. They were making best out of the worst. That means waste, and they were making exotic fashions out of patches. जो कपड़े काट के जो कोने निकल जाते हैं पुराने, they had made fantastic, and they were using, this is the kind of waste, feed the numbers, feed the approximate sizes, just scan 10% of the volume, and through AI, it would give the best nice designs. I'm talking about fashion design. Now that stuff, even fabric designs, of course it can give 5, 6 ways of looking at it, you can select one. Similarly, one can actually, जो 100% हमारा wastage होता है ना, उससे कम से कम, at least to my understanding, we'll be able to re-employ 70% of the waste. थोड़ा सा अगर हम, why we are talking this one? Because we're talking about future being safe and smart. So using parameters, हम लोग 70% waste को दोबारा use कर सकें. And I'm reaching to a point when he said net zero. Future is not net zero but net positive. There's nothing called, there's no greatness in net zero. The greatness lies in net positive. अगर हम positive start producing करें, so the only thing which I see smartly, and I really want to harp on this point because we don't want to take much time here, I'll open some questions, is if we can use the computation tool, let's put the approach of parametrics, and use it to manage our waste, manage our time, manage our resources, and yet with the help of AI, we can also give some fast, it does not take away your creativity, it only gives 10 more extra. You can still go 10 more by yourself, no one stops it. So kam se kam, this thing will give you a very fast way of re-employing your wastage, re-employing your time smartly. So we should enhance and institutionalize our practice or our manufacturing using the tool. Now having this one, we understand that we were only given about 30 minutes and we have taken a little more time, the others, etc. I think that you heard the panel. मैं चाहूँगा कि हम लोग some questions we can prompt. कुछ भी, you know, we can understand that if we have something, well, how can we do it, or if anyone wants to say. You have seen some concerns, but you've seen a lot of support also in the entire thing.
Excuse me, I would love to add something actually. So when you're talking about computational design, people are just thinking about it's just about software. People are just playing around and creating forms, but that's not the case. So what's happening in computational design is we are able to alter the software itself. So the attitude of the designer is in such a way that they change the tool, they change the materials sometimes, they change the software, they change the electronics. It's about change. So once you're sticking to traditional materials, etc., I think there definitely would be some wastage. But with the computational design attitude, so let's talk about materials also, material innovation.
Absolutely.
So architects do that actually. I mean, I showed in my project, but I'm just using cardboard. I created my custom material. So you're using a custom software sometimes. So this is the attitude actually. It's not just about existing things. It's about creating entire new, paradigm into material, software, execution, systems of all ranges actually.
Very nice. And that's just to add to your point, the GI wires that we're using a weaving design patterns of smart way of handling this thing, the entire material, that is partition system, was developed using GI wire, जो कि हम लोग fence में use करते हैं, ordinary binding wire, let's put it like this, binding wire type of patla wire. One can develop as strong as accidental nets, which is basically to stop accident, safety nets in terms of transport. Itna strong netting, and this comes out because options of netting, knotting. So this is the things which can happen. Many samplings can be created very fast. So it's a very advantageous tool. We should be very proactive, looking forward to inclusive, not abortive, but inclusive approach in the entire design. Any questions? कोई तो question पूछ लो यार. तो कुछ तो पूछ लीजिए. Yeah, you want to ask? You have a mic?
If I have understood rightly, Mr. Sridhar was talking about scaling with parametrics. Now, one thing which we come across every now and then is that every person, when he's looking for a product, he wants something novel, something new. Now, if you scale up and you go on producing the same kind of table everywhere, not everybody will buy the same table. So how do you scale it up?
So in my presentation, I was talking about the generative aspect of computational design. So why computational design is a completely different paradigm compared to previous architectural styles is we are using digital systems and then we are not creating one product actually. So we are creating a system, an algorithm maybe, for your understanding, something like a generative algorithm, which will create multiple, product line actually. I mean, the product will remain same, but some parameters will change, and then each product turns out to be completely differently. So you're not creating one product, but a system of computational design. No, we are creating one system which can create multiple systems.
So, yeah, I'll just make it simple. To grab, if I can understand your point, is scalability would have come very fast using CAD-oriented manufacturing. You just volume बढ़ा देते हैं, you can do it. But here, because they are so smartly they're handling the parameters of control, the word is customization is much more easy. Your question is, customize.
Wherever customization is involved, the scaling up it has limitations. Like if I make the same iPhone, I can make in lakhs. But each time if I have to change some parameter in this iPhone, I have to design it separately. Each one has to be designed. Now you get a parameter, by algorithmic thinking, you can have a pattern. You are repeating that pattern in different ways. But that different way, each different way is a different product, right? So that means when you are scaling it up, each time you are making a different product.
Okay, let me answer this question. So if you're using generative algorithms, you have multiple designs now, and when it comes to manufacturing, generally the passive traditional manufacturing process is mostly mold making, if you understand. Like for example, if you're talking about electronic cases, for example, or a bracelet or something. So there is this additive manufacturing, which is popularly known as 3D printing. So every time you don't have to create a mold, so mold making is expensive, you can pump out multiple plastic pieces out of it. But the thing is, 3D printing doesn't have mold making process. You can skip this part.
So very making simple, I think there is a need of smart manufacturing which couples together with the parametrics advantage. So both have to go take the better advantage. I still see a lot of faster customization possible with parametrics, aided manufacturing and design. So any more questions? Haji, can we have the mic there, please?
Bivek, the question is parametric design in our futures, but for cost effective, is it possible for low cost housing or for middle class people?
So let's talk it today or tomorrow. Tomorrow, yes, definitely yes. And I'm just making a point on behalf of the contingent which is already there. Today, little difficult because for a mass housing, modular consumption can be very well be made out of stuff using parametrics very fast. When I go to scale, I need to get into printing. The day our cost of 3D printing in terms of construction printing technology comes there, it will be the most fastest and the smartest way to doing it. And this has been already there. This is expected to be less than 3 years down the line. In many countries, it is already there. The other thing is, there are so many factors. Example I'm giving you. Parametrics is about number of layers of analysis. Okay, it's very. In my case, I was to program AutoLisp when AutoCAD used to be there. I think an AutoCAD used to be there at time. AutoLisp used to be there, which allowed you to go inside and modify it and have AutoLisp, if you know. I think now it's all gone there. But having said this one, using smart way, giving an example you'll understand, there was a need of making strong paper. So people usually went to honeycombing. The new way of computation told them the new way of honeycombing and consuming 1/3 the material it gave to a same strength of paper. Am I right? So the day we will be able to produce it so faster, which is already coming, not far off, less than 3 years, it will be the best, cheapest way to doing it. Because I remember Laurie Becker making 55,000 rupees mein ek house, 55,000, he was using brick. Now the brick is becoming very expensive to make the any houses. Hame brick hi nahi milta hai, so we go for concrete maybe. And now they're saying mud-screte, that is mud concrete printing will be the cheapest and it will be almost close to that. In that range, उस time में 55,000 था, तो इस time में जो 40,000 होगा, वो पे मिल जाएगा. तो mud-screte is concrete using mud. 3D printing will give the same solution for a large-scale housing. You had one question, anyone had? Yes, please. Can you share the mic, please?
Good evening. Experiencing such a wonderful presentation, I just have a small question. See, we also have so many budding designers over here. So, to Mr. Sushant or to any panelist, can you give a one-liner to our new designers so that they can also be confident? Otherwise, they are thinking it may be something which is rocket science, a robust kind of thing, doing designs with parametric. If you can give them advice, they can even use this in their mainstream design so that they can be confident enough.
So, I mean, one liner would be very difficult to give, but I think I would like to say, I mean, to all the young people out there, like, you have to stop chasing software. And that's the problem with not just the young people, but the old people as well, to be honest. Like, you have to stop chasing the software. All of this, what we're talking of right now, is not about the software, which is something Sridhar also mentioned. It's a technique, it's a technology, it's to aid us in a process, whether it's usable for your own technique, whether it's usable for your own style that you wish to develop, that changes from individual to individual. So I think it's, I would say, I mean, technologies will keep changing. It's your approach towards the profession that matters the most. And when I say that, I go back to the roots of architecture, roots of how I run the practice also. Like I tell, I don't think in my studio I anywhere talk about what softwares you want to use. I actually talk about discipline, I talk about, you know, persistence and all of these kind of things, which I think matters as a professional. So softwares take a backseat, technologies are there, but yes, they are there, you need to learn them, you need to adapt to them, if you really want to utilize them to do something good. And everything is not meant to be learned by everyone. There are experts, so there is a reason there are experts. There is a reason there are 3 parametric experts sitting here right now, you know, so we exist for a reason, to help other people out as well. There is a reason a structural consultant works in structure, like architects cannot do that. So I think focus on the process of designing what you intend to do as a designer. That is more important than the tools and the techniques. Probably 10 years back, I would have not said that, because I was also trying to learn as many softwares as I can. But through a period of time, I've also realized that it's not only about the software, it's about what your approach towards the profession, what you want to design, how you want to design something. That matters the most.
Good. Well put up, Sushant. Can I go offline, because I have got the letter. The letter says that wind up yesterday. Okay. So we will discuss it out. I'm sorry, because we have been adding up to the delays, and the organizers are very hungry also, you know, before I say angry. Thank you very much, audience, and thank you very much, panelists. You have been quite clear and the best that you can add to the grace of the panel.
That was a very interesting debate on computational designs versus the conventional ones. And I think it will take some time for our generation maybe to adapt to the computational part, and the younger generation would definitely lead us to adapt in this adaptation. I would request the panelists to be seated. We have a small felicitation ceremony. Can I request Mr. Raja Sinha, Vice President Abbott, to felicitate Mr. Sushant Verma? A big round of applause for architect Sushant Singh Verma. May I request Treasurer Mr. Mukul Bothra to present, to felicitate Mr. Monish Rirapuru. Round of applause for architect Monish Rirapuru. I request our Secretary, Mr. Karan Jain, to felicitate architect Sridhar Mamidala. Big hand for architect Sridhar Mamidala. I now invite Mr. Abhijit Saha to felicitate Mr. J.P. Agarwal. Please join your hands for architect J.P. Agarwal. I invite past President Mr. Atul Bothra. Mr. Atul Bothra to felicitate Mr. Kamal Periwal. I invite Mr. Sanjay Kacha on stage to felicitate architect Vivek Singh Rathore. Big round of applause for architect Rathore. I request the panelists to kindly be seated on stage. We have a few more presentations. We had conducted a students' contest for parametric design reels. Received a number of outstanding entries for the same. Yeah. They've shown exceptional talent and creativity. And after careful consideration, the jury have selected 3 outstanding entries for the students' reels competition. And may I invite Mr. Apurva Manoj Mrigul from IIEST Shibpur, who's made a brilliant, a very outstanding design on the parametric. Request Mr. J.P. Agarwal to present the award to Apurva Manoj Mrigul. Big round of applause for Mr. Apurva Mrigul. Can we play his reel on the screen, please? He is from IIST Shibpur. I now invite Daita Maiti from IIST Shibpur. Request Mr. Vivek Singh Rathore to present the award to Ms. Daita from IIST Shibpur. Congratulations, Ms. Daita. Your reel was exceptionally. Nextly, I invite Mr. Gaurav Sharma from INIFD. INIFD. Mr. Kamal Periwal to present the award to Mr. Gaurav Sharma. for his exceptional presentation. Big round of applause for Mr. Gaurav. That's the reels prepared by the students. We congratulate each of them for their outstanding contributions. Thank you all the participants for showcasing your remarkable talent. Before we move ahead, I would like to invite Mr. Amit Chaudhary on stage. He's sponsored the brilliant furniture on stage, and he would, can we have a memento for Mr. Amit Chaudhary? I request Mr. Kamlesh Agarwal to present the memento to Mr. Amit Chaudhary. And believe me, he made all this furniture within 3 days. Amit ji, you can speak on the mic and...
Okay. All right, guys. I made this in 3-4 days. If you see that podium, it was a dining table base. But lastly, I thought how I'm going to convert it to 29-inch height top base to 42 or 40, whatever. So we just turned it around, put some base, and it's the same. So the whole, whatever the furniture you see, it's done from the 2 sheets of 8x4. 0% wastage, basically. And I love to create them. That's it. Thank you.
So that is the formula of Amit, how he can make money.
Yes, of course. So no wastage. India is a poor country. We cannot afford wastage. Isn't it? We are a growing country. That's what. Thank you. Thank you all. Thank you. Thank you, Kamleshji. Thank you, Abid. Thank you.
I would request our past president, Mr. Ajit Singhi, to propose the vote of thanks.
Good evening, ladies and gentlemen, distinguished luminaries, friends and fellow members. What an illuminating session we had this evening. Seldom do we find a scholarly discussion so engaging. It was in fact so engaging that we saw no movement among the audience. Normally, we see people going up and down, but everybody almost looked like as if he was glued to the seat. While some, particularly the speakers were very captivating, while some showed us the algorithmic thinking and how the form changes and flows like a poetry, the other insisted on the use of AI and the computational design. They amply demonstrated how algorithmic thinking extend our creativity. In panel discussion, they insisted on viewing technology as a tool which can be used or abused. Technology is an unstoppable thing and it is ever evolving, and it depends on the user how he uses it. Their viewpoint differed, but what was common among all of them was they were all captivating. Sir, each one of you have left an imprint which is difficult to be obliterated. Our president, Mr. Kamlesh Agarwal, so rightly said, when he said that this discourse tonight will go a long way in honing the designing skills of our fraternity. We are no less thankful to the distinguished architects who so graciously condescended to participate as panelists and speakers. We are thankful to our speakers, to our sponsors who make available to us the wherewithal to organize an event like this. We are thankful to the friends in media who are ever patronizing us, and we are also thankful to our President, Mr. Kamlesh Agarwal, who is so receptive that when our convener, Architect Deepa Agarwal, coined this idea of holding a conference on parametric design, he readily accepted it. And on her part, Mrs. Deepa Agarwal with her team, particularly the working committee, they toiled day and night and they have put up a grand show which really becomes us. Finally, we are thankful, taste of pudding is in the eating, and taste of a seminar is the way the audience receives it. With the kind of attendance we have and the kind of applause we received, that it was a very successful seminar. And I would like to thank all the invitees and the audience who found time from their busy schedule, keeping their tradition, made it so smooth for us. Thank you. Thank you, everybody.
Thank you, Ajit ji, for your kind words. I request all the speakers and the committee members on stage for a photograph. Can we have the speakers on stage for a photograph, please? Speakers and the panelists, please. Kamal ji, JP ji, Mr. Sushant Verma, Monish ji. And I invite the working committee and the executive committee along with the seminar committee on stage for a photograph. I request everyone to join us for cocktail and dinner.